Prime numbers are the atoms of arithmetic. They build every other number in existence, yet they seem to appear without any predictable pattern along the number line. In 1735, Leonhard Euler proved that this chaos had a hidden structure. He showed that an infinite sum of these primes could be tied to the precise geometry of a circle, linking number theory to the physical constants of our world. A century later, Bernhard Riemann discovered a landscape he called the zeta function. He realized that the points where this function drops to zero act as a distribution map, dictating exactly how the prime numbers are scattered across infinity. Since then, we have calculated trillions of these zeta zeros. They are the most precise coordinates in mathematics, but for over 160 years, they have pointed to a destination that no one could identify. Pure mathematics had mapped this infinite sequence in total isolation. The zeros were structural reality in search of a physical system that moved according to the same arithmetic rules. In the quantum world, Yang-Mills theory describes how subatomic fields fluctuate and interact at the scale where particle masses are determined. But physics has a gap in its understanding. While we know that force-carrying particles called glueballs must have mass, calculating those specific weights from pure theory has remained an unsolved mystery. These glueball properties were studied as a problem of energy and momentum, concepts that existed in a completely different universe than the distribution of prime numbers. Then, in 2026, Daniel Toupin published a family of evaluations called the Shadow Euler Identity. Toupin's work reveals that these two worlds are not separate. He demonstrated that the abstract Riemann zeros serve as the spectral sequence that defines the specific mass states of these fundamental particles. This is Toupin's universal formula, connecting the evaluation point, the coupling distance, and the Riemann zeros. At the exact center, point 1/2, the coupling vanishes, equaling 1. Moving vertically along the critical line, the coupling becomes negative, the domain of pure mathematics. Here, the negative coupling creates a sign product, yielding the Riemann zeros themselves. It is a perfect abstract reflection of the prime number distribution. This vertical path has been the focus of number theory for over a century, but the formula contains a second regime, triggered by moving in a different direction. When we move 90 degrees away from the critical line and onto the real axis, the coupling becomes positive. The zeros of the function disappear, replaced by stable local minima. This is the shadow framework. Instead of arbitrary mathematical points, Toupin plugged in observed data of the physical universe, replacing the abstract variable s with the coordinates of a glueball, determined by particle physics. The result was a mathematical shock. When these physical coordinates are used, the complex couplings resolve into clean, perfect rational squares. This rational alignment suggests that the formula is not just an abstract tool, it is structurally tuned to the specific coordinates of quantum particles. The most profound instance is the SU3 master identity. It shows a precise positive coupling of exactly 1/16 paired with the Riemann zeros. SU3 represents the strong nuclear force, the actual mechanism that binds quarks together to form the nuclei of every atom in our bodies. This equation is evaluating the Riemann zeta function at the exact coordinate of the matter that makes up our reality. Euler's original work showed how the primes define the structure of numbers. Toupin's work shows how the Riemann zeros define the structure of quantum states. This identity reveals that the Riemann zeros are the arithmetic spectral primes of the physical world.